All right, today's lesson is going to be about graphing parabolas in vertex and intercept form. So we've been graphing parabolas already. Now all we're going to do is kind of change the form that we're looking at, and hopefully just by looking at the form, we'll be able to pull out kind of the important parts so that we can graph it without having to necessarily rely on our calculator. Now with that said, you do have the option of using your calculator, right? Use all of your resources, that's what I'm all about. So we'll make sure that we all know how to do this on the calculator as well. So as a warm-up question, we have kind of a question from our last section. Currently, this is in standard form, right? Ax squared plus bx plus c. In order to find our maximum or our minimum, I need to just ask myself, well, is it going to open up or open down? Since I have a positive 1 in front of my x squared, that tells me that it's going to open up. So if it opens up, it therefore has a minimum and no maximum. Now, the next question asks for us to actually find what that minimum or maximum value is. So in order to do that, we're going to use our one formula that we have to memorize, right? Negative b divided by 2a. So I take negative b divided by 2 times a, and I get out 3. So that tells me at x equals 3, 1, 2, 3, that's where I'm going to have my axis of symmetry. And if that's where my axis of symmetry is, then that's also where my vertex is going to be. So in order to figure out what that vertex point is, I'm going to plug 3 in. So 3 squared minus 6 times 3 plus 4. I get out negative 5. So my coordinate point is at 3, negative 5. Let's make sure. Yep, there we are. Now I know the graph opens up, so I know it's going to be kind of going up here. The other point that I'm going to need to graph is my y-intercept, and the y-intercept is always that last number there, so it's at 4. So there it is. And then I'm going to take that and I'm going to reflect it over my axis of symmetry, and then last but not least, I go ahead and connect the dots. Ooh, not very well drawn. Let's see if I can draw that a little bit better to get that U parabola shape. All right, so that concludes our warm-up. Let's move on to kind of our newer topics, which, to remind ourselves, we're going to be learning 2 different forms today, vertex form and intercept form. We have seen these before, but now we're going to give formal names to them. So let's look at what vertex form looks like. And vertex form, you'll notice as soon as I start writing it, you will notice this form. So it looks a lot like when we've studied other functions, right? In Unit 3, when we talked about transformations, we had this form. Now on Unit 4, when we studied absolute value, we saw this form, but these were absolute value bars instead of parentheses. Same thing here. It's now called our vertex form of a parabola. Now to be able to pull out the actual vertex value, it is h and k. And notice there's a negative sign in here, so that tells me I take the opposite of h. Therefore, because my vertex is at hk, I already know where my axis of symmetry is. It is x equals h, and that h, whatever that number will be, it's the opposite of what's going to be in the parentheses. It will open up if the absolute value, if a is greater than 0, it will open down if a is less than 0. So if my a is positive, I have a right side up u. If a is negative, it will be facing downward. It's going to be wider, or what sometimes, right, historically we call compressed, if my absolute value of a is less than 1. So if this is some kind of fraction, 1/2, negative 1/3, we're going to have a fatter, wider parabola. It's going to be very narrow and have a very exponential kind of fast path of going up and up on both sides, or narrower if my absolute value of a is greater than 1. My domain, like all parabolas, is negative infinity to positive infinity. And then my range is going to either go from negative infinity up to, and I'm going to use this k value here because it is part of our vertex. So k either becomes the highest point, right, the maximum point on the parabola, or k is kind of our minimum point, and then we go to positive infinity. So this just depends, right? If you have a downward facing parabola, this is going to be your range. If you have an upward facing parabola, this is going to be your range. So now let's get into a couple of questions to make sure we know how to look at this form and graph all the pieces that we need. Because remember, in the end, our learning target is really just to be able to graph these functions. So in my first example, I look at the number out front and I say, does it open up or open down? Well, it's negative. It's a -1, so it's going to open down. So if it opens down, it therefore has a maximum. My axis of symmetry, thankfully I don't have to do a lot of work here. I just take the opposite value of what's in the parentheses. So my axis of symmetry is x equals -1, and my vertex therefore falls on -1, 5, right? The nice thing about this form, it's called vertex form because the vertex will stand out to you. So let's go ahead and graph our axis of symmetry here. And then on that axis of symmetry, I'm going to graph my my vertex, right? -1, 1, 2, 3, 4. So there we go. My y-intercept, now here's where we might have to do a little work because my y-intercept does not stand out to me with vertex form. It stood out to me with our standard form, but the y-intercept does not stand out to me. So we have to use our understanding that a y-intercept will always have an x value that is equal to 0. So I'm going to plug in x is equal to 0 into my equation up here and see what my y value ends up being. So I get y equals -0 plus 1 squared plus 5. And here's where I just have to make sure I know how to evaluate. Now, yes, we can definitely put this in the calculator and see and double check our work on Desmos and all that fun stuff, but I want to make sure that I also know how to do this algebra. So I evaluate my parenthesis first, I get 1. I then calculate 1 squared, which is still 1. I then tack on a -1 out front, so I get -1 squared plus 5, which equals -1 plus 5, which therefore means my y-intercept is at 4. So I go ahead and plot that, and I'm going to reflect that over the other side. Now here's where it comes into play that, oh, you know what? I don't know if I have enough coordinate points to really be able to graph this. So I'm gonna, for the first time, why don't we jump over to Desmos and check this on Desmos? So if I jump over and open up Desmos, click on my graphing calculator. I'm going to type in the function exactly as it looks on my paper here. There we go. So I see that point 0,4. Let's see if we have another point. Well, unfortunately, my x-intercept is not a nice round number. So I need to try to find a nice round number on my parabola here. Oh, I see one. It's at 1, 1, or you always have the option of changing this into table form where I can see, oh, yep, I've got 1, 1 on there. I've also got 2, -4, so I've got a couple different points that I can use. I'm going to go back to my notes and say, well, I've got the point 1, 1, and I can kind of reflect that over. I've got another one here. There we go. I would say at that point, if you've got 5, you have enough to graph your parabola. Now, narrower or wider or the same, if the absolute value of your a value is equal to 1, it's going to have the same width as kind of our parent function, which is just x squared. So in this case, since this is a -1 out front, it will have the same width as your parent function x squared. My domain is always negative to positive infinity. And then my range, in this case, right, the highest that it ever goes up is 5. The lowest, negative infinity, I always want to put the smaller number first, and then I use the bracket to indicate that it gets all the way up to 5. Right, I recommend at this point maybe pausing the video and trying the next example on your own before I go through it myself. Right, so let's look at our next example. We have, here I'm going to start up my calculator, my parallel desktop, while we get started with this one. Right, while that gets booting up, let's go ahead and look at this one. Well, I have a positive 1/2 out front, so that tells me it's going to open up, right? If it opens up, it's going to have a minimum. My axis of symmetry stands out right away, right? I just take the opposite value of what's in the parentheses, x equals 3. My vertex, therefore, is at 3, -5. So let's go ahead and plot that information. So far, we've got our axis of symmetry. And then we have 3, 1, 2, 3, 4, 5 down here. Perfect. Now my y-intercept, right? I'm not sure what my y-intercept is, so I'm going to plug in 0 up here, and we'll see if we get out a nice round number. Who knows, right? So I'm going to do f of 0, because I'm going to plug in 0 for x. So I get 1/2 times -3 squared minus 5, which means I evaluate, right, my exponent first. So I get 1/2 times 9 minus 5, which means I get 4.5 minus 5, which is just 0.5 or 1/2, however you want to write it. Sorry, negative, right? That's going to be negative since we're subtracting 5. So if -1/2 is my y-intercept, well, I'm glad we found it, but it is pretty hard to graph on here. I mean, I can kind of do my best here and then go ahead and reflect it over. But it really might be a case where we might want to plug this into a calculator to get a few more points. So let's go ahead and make sure we also know how to do this on our calculator. Sorry, my computer is running on some updates here. Oh, you know what? That's taking way too long. So let's see if I can just come back and put this into Desmos instead, hopefully by the time this is done. So I've got 1/2 as my function, as my a value, and then I have x minus 3 squared minus 5. So there's our parabola. I see our -1/2. I see our vertex down here. We're doing all the right things. Let's see if we can find a couple more table of values. Well, you know, -1, 3 looks like a good point. So let's go back over here. And I've got -1, 3. 3, perfect. And then I'm going to reflect that over to the other side. Now I feel like I probably have enough points that I can go ahead and graph it. And you'll notice right away, right? It's definitely a bit wider than our original. And because this a value is less than, the absolute value of it is less than 1, that's why it's wider. My domain, as expected, negative to positive infinity. And then my range is going to go from -5 all the way up to positive infinity. So that kind of concludes our introduction to vertex form. And I'm hoping with all the work that we've done in Unit 3 and Unit 4 that it's not too overwhelming. We can get a handle on vertex form. So let's switch over to our next form, which is called intercept form. So intercept form, and of course, to make sure that we use all the different letters of the alphabet, really what they're trying to do is make sure that we don't get confused between each form, which is why they use so many different letters of the alphabet. We have our a value out in front, but now in intercept form, it's really what we call factored form. So it's going to be factored out for us. Just remember back to, right, we'd have x squared minus 5x plus 6, and we'd have to figure out, okay, how do we factor this? What two things multiply to give me 6 but add to give me -5x? And we'd factor this down as x minus 2, x minus 3. This is basically, I've taken our standard form and I've already factored it out for us. The nice thing about this form is it gives us the intercepts. And when I say intercepts, I mean it gives us the x-intercepts. So I now know that one of my x-intercepts is p, and my other x-intercept is q, right? Because remember, when we factor these, in order to find the zeros, find the x-intercepts, I then set each of these equal to 0 and I solve, which means I wind up getting the opposite number for my x-intercept value. So that's why you take the opposite of P and Q, and that becomes, right, your x-intercepts there. In order to find your axis of symmetry, basically, whatever your x-intercepts are, your axis of symmetry must fall in between them, perfectly in between them, halfway in between them. So since it's halfway in between them, I go ahead and I add P and Q together and I divide by 2. Basically, you're finding the average between your x-intercepts, and that will tell you what your axis of symmetry is. Now, this is very similar to our standard form. Once I have the x value of my axis of symmetry, to find the whole vertex, right, the whole coordinate point, I plug in x to find the coordinate, to get the full coordinate, which is what I need for my vertex, right? In order to get the vertex, it has to have an x and a y component. These are all very similar. It opens up if a is greater than 0. It opens down if a is less than 0. So if I have a positive a, it still opens up. If I have a negative a, it opens down. It's going to be wider or a fatter parabola if the absolute value of a is less than 1. And it's going to be narrower if the absolute value of a is greater than 1. My domain always goes from negative infinity to positive infinity. And my range, the same kind of idea, right? It's going to either go from negative infinity up to y, and that's my y value of my vertex, or it's going to go from y up to positive infinity. So this is y value of vertex. All right, so now that we kind of have an outline of what intercept form looks like and how it works, let's look at an example. So my first example, I've got a negative out front, so that tells me right away that it's going to open down, and if it opens down, it therefore has a maximum. My x-intercepts, I don't worry about what's going on up front. I literally just look inside to the parentheses, and this tells me that my x-intercepts, my first one is at 4, and my other one is at -2. So I'm going to go ahead and plot those. Got 1, 2, 3, 4, -2. Now, in order to find my axis of symmetry, I go ahead and just add my two x-intercepts together and I divide by 2, right? I'm just trying to find the midpoint between these. So I get 2 over 2, which is 1. So that tells me my axis of symmetry is at x equals 1. Or you can always kind of just count it, right? What is really the halfway point between these 2 points here? Now my vertex, I have to figure out, right, is it up here? Is it down here? What's going on? So I'm going to take this 1 and I'm going to plug it into my equation. So I get y equals, keep that negative out front. I'm going to evaluate my parentheses. So 1 minus 4, -3, 1 plus 2, +3. We multiply all this together, we get 9. So therefore my vertex is at the coordinate point 1, 9. Let's make sure I have that on my graph. Here we go, all the way up at the top there. So at this point, I do think we can draw it, right? We have one all the way down here. We know it's going to look like kind of like that. Sorry, drawing on this drawing tablet, not the easiest thing to do. All right, so we have our parabola. Now it does ask for the y-intercept. So in order to find the y-intercept, I'm going to have to do the same process that I did last time, right? For a y-intercept, I'm going to plug in x is equal to 0. So let's figure out what we got there. When I do that, I get +8. Oh, good. That's exactly where I put it. And I should have reflected this and drawn that a little bit better. There we go. So my y-intercept is at 0, 8. My a value at front is a -1. Remember, if your a value is 1 or -1, it's going to have the same width as our parent function, y equals x squared. My domain always goes from negative to positive infinity. And in this case, right, my range, since it opens down, it goes from -infinity up to 9. I encourage you to pause the video at this point and try the next example on your own before I go ahead and put it up. All right, so we got a little bit of a strange one here, but I notice basically, right, if you need to rewrite this with placeholders, you've got a 1 out front and then you've got kind of a 0 grouped with the x, right? There's nothing within the parenthesis here, so it's really like you're adding 0. Since it has a positive number out front, it's going to open up. So since it opens up, it has a minimum. My x-intercepts, well, my first one is going to be at 0. There's really no opposite of 0, right? The negative of 0 is just 0. And then my other one is at 4. So I've got 0, 0, and I've got 4. Then I go ahead and I plot my axis of symmetry. Notice with this one, I really didn't have to do the math. I could tell right away that the number in between these two was just the number 2. But in order to find the vertex, I do need to plug in 2 into my equation up here. And I get out that it's at -4. So I've got 2. Now in this one, the y-intercept is the same as the x-intercept. It stands out right to me. It's just 0, 0. Since the a value out front is a 1, it's going to be the same width. And then let's go ahead and draw this. So we've got our parabola. My domain goes from negative to positive infinity, and my range is going to go from, what's my lowest value, -4 all the way up to positive infinity. So hopefully, kind of learning those different forms, not too bad, things that we have seen before and really just kind of applying them in principle and kind of taking more specific notes about them. Let's move on to some word problems and how we change forms. What's the algebra between changing forms? So here's a word problem here. If an object is propelled straight upward from Earth at an initial velocity of 80 feet per second, its height after t seconds is given by our function h of t equals -t times t minus 5, where t is the time in seconds after the object is propelled and h is the object's height. So these are the classic parabola questions we see, right? A basketball is being thrown, a rocket is being propelled, whatever the case may be. Anytime there is that type of shape, right? If we have a shape of something being thrown or a rocket being propelled, it's going to have a parabolic shape, which means we can use a parabola, a quadratic function, to track its progress. So the question asks, how many seconds after it is propelled will the object hit the ground? So if we think about it, right, on the coordinate plane, and we think about this function, what form is this function in? Is it in standard form, vertex form, or intercept form? Well, it's already in intercept form. And the x-intercepts of this function will tell me when it is on the ground, right? Because we've got kind of our function plot here where my x value is the time, and we need our height here, right? We want our height to be at 0, so when the height is at 0, those are the x-intercepts. So all I really have to do is find out what my x-intercepts are. Well, my first function out here, right, if we need to put in a placeholder to kind of help us see it, it really means a +0 there, and then a t minus 5 there. So if I were to set this equal to 0 and solve and all that fun stuff, I would get that at time 0, right, before it's even left, its height is 0. And that kind of makes sense. Now, the other one, t equals 5, that tells me at 5 seconds is when it returns back to the ground. Pretty interesting. So 5 seconds is really the answer that we're looking for there. Now, to find the maximum, right, it's going to be up here somewhere, and we know it's going to happen at a time of 2.5 seconds. So therefore, I'm going to take time of 2.5 and say that's when the max occurs. Therefore, in order to find the height, I'm going to plug it into my equation. Right, gonna have to do a little math here. Get out my calculator. So I end up with negative 40 times negative 2.5, right? I should hope I get out a positive number. It would not make sense to not get a positive number, so I get out 100. So therefore, the projectile, the object, whatever it is, right there, it's going to have a height of 100 feet. So really looking at the form that is given to you and then kind of exploiting that, right? Understanding, oh, with this form, it gives me my intercepts. With this form, it gives me my vertex. Use that form to your advantage because it will really kind of help you answer these questions more quickly. Okay, let's get into the algebra of changing forms. So usually students don't mind this too much because you guys have great algebra skills, so rely on those algebra skills. What I have here are functions that are currently in intercept form, and I want to change them into standard form. So in order to do that, remember our standard form. It's really the kind of classic form that we see probably the most. It's going to be our ax squared plus bx plus c. When you start with intercept form, what you're going to want to do is you're going to FOIL and then distribute, or at least that's my recommendation. That's kind of where I see we won't make the most mistakes. So I'm going to keep this 3 outside, and I'm just going to kind of take care of the inside first. So I'm going to FOIL. I'm going to kind of do it all out, right? X squared plus 6x minus 4x minus 24. I then go ahead and combine my like terms. If you can start doing that in your head, kind of combining those like terms, it will save you a good amount of time. I do encourage that. And then last but not least, I'm going to distribute this 3 through to all of the different parts. So I wind up with 3x squared plus 6x minus 72. And that is our standard form. Whether you have y equals or f of x equals, it is in the form that we need. I recommend you pause now and try letter C on your own before I put up the answer. Notice in this one, I kind of skipped the step, right? I combined my like terms, and then I go ahead and I distribute that negative sign through. And I am left with the standard form of this function. It started out in intercept, and now it is in standard. On the next page, or sorry, not the next page, on the same page, but letters B and D, I'm going to be starting with a different form, right? This is my vertex form, and I want to get it to standard form. Right, we're still following the same kind of instructions here. And it really is kind of the same thing. You're going to FOIL first, you're going to distribute, and then the very last step, you're going to have to add that 35. So we're going to take care of this part first. We're going to evaluate our exponent, then multiply, then add, just like we would with order of operations. Because remember, right, this x plus 8, the quantity squared, that means this. Right? We do not bring the 2 inside or any of that. Because I am adding in here, I must FOIL out. So I get x squared plus 16x plus 64, and then I've got my plus 35 on the end. Notice I'm only going to distribute this through my FOILed parabola, right? This plus 35 is not part of the distributing deal. So I get f of x equals negative 1/2 x squared minus 8x minus 32. And now I'm going to go ahead and add that 35 together. So my final answer that I get out, the standard form of this function, is negative 1/2 x squared minus 8x plus 3. I encourage you to pause the video right now and try letter D on your own. Remembering, right, this right here is the quantity x minus 1 times x minus 1. And I'm going to kind of go a little bit fast here, right? I'm going to combine my like terms all in one step here. Then I'm going to distribute my 3 through. And then last but not least, I'm going to combine the 4 with the 3. So there we have it. I know these notes are quite lengthy. I do apologize for that, but let's keep moving on to finish up the rest of 5.2. On the back here, and honestly, this is really good review for the final exam coming up. We want to write a quadratic form in vertex form by completing the square. So completing the square, that was from section 2.5. And I'm hoping that as we kind of go through this process together, you will start to see some things that remind you of this. If you struggle with this, I encourage you to keep working at it because you will see this in pre-calculus if you continue on to pre-calculus. So let's go ahead and follow the steps that it tells us to do. So the first thing it tells us to do is group the terms with the variables. So variable, in this case, it's an x value. So I'm going to group, meaning I'm just going to put some parentheses around the 2x squared plus the 36x. Plus 995. Now this next one says, make the leading coefficient equal to 1 by factoring out the coefficient of x squared. So I'm not going to worry about factoring out a 2 from 95. I'm just going to factor out the 2 from within here. And you'll notice when I do this, I end up leaving a bit of a space here. So when I factor out a 2, right, I've got to divide 36 by 2. Yes, you'll notice, right? I left this here. Now here's the completing the square part. I add half of b squared to my group and subtract the same amount you added outside of the group. So here's what we mean by that value. I take half of 18, which is 9. I then square that, it's 91. So I'm going to add 91 in here in the 81, 81. I add 81 in here inside the parenthesis. But did I really add 81 or did I add 2 times 81, right? Notice what I really did when I added the 81 inside the parenthesis here. I really was adding 2 times 81, which is 162. And I'm not really allowed to, if I have a function that is y equals x, I can change that function to be y equals x plus 5, but then I've got to subtract the 5 at the end, right? In order for this function to stay the same, if I add 5 here, I have to subtract 5 out here. If I have a 2 out here, right? Say this is a 2x. If I add 5 here, I'm not really adding 5, I'm adding 10. So I need to then subtract the same value out to make sure I keep the exact same function that I started with. So I still have this plus 95, but now I have minus 2 times 81. Pretty tricky here. So let's kind of, in the middle here, kind of combine our like terms to make sure we kind of know what's going on. I've got 2. Instead of writing it this way, I'm going to write it as the binomial squared. So if we remember, this is x plus 9, the quantity squared, and then I've got my plus 95 minus 162 out the end, which means I'm going to finally do the last step here, combine all my like terms. So that was the long process of taking a standard form function using all your understanding of algebra and rewriting it in vertex form. Remember, the nice thing about vertex form is your vertex stands out to you. You take the opposite of this number, that's your x value, and then whatever this value is, that is the y value of your vertex. I encourage you to go back and rewatch that if that's something, you're kind of struggling to follow along with. But hopefully, as we do these next couple examples, you'll start to kind of see that pattern or be reminded of that pattern from 2.5. All right, so let's look at letter A. Well, the first thing is I don't have any 2's out front to worry about, so that's nice. First thing I'm going to do is I'm going to group my variables together. My next step, right, is I'm going to take half of b, so this value here is a -8, half of that is -4. -4 squared is 16, so I'm going to add 16 here. But if I add 16 here, I have to subtract 16 at the end. I then have all of this here. I'm going to rewrite this part here as a binomial squared. And that binomial squared is the quantity x minus 4 squared. And then I combine, right? 17 minus 16 is plus 1. So I know initially, right, we had all of these steps that we went through, our nice 5-step process. Well, the more you do this, the more you will be able to kind of shortcut it quite a bit, especially if you leave some space in your function as you write it out. My vertex, then I take the opposite value of what's with my x, and then what's at the end. So my vertex is at 4, 1. Let's go ahead and try letter B. Oh, we do have a 3 here, so let's see. Might have an extra step or 2 in here. I'm going to group my x values together. I'm then going to factor out the 3 from those two. So I have x squared minus 4x. Here's where I'm going to leave my space. At this point, you look at this letter B, right? We're not referring back to this letter B. We're now just working with what's in the parenthesis here. So I'm going to take half of -4, which is -2, and then -2 squared is positive 4. So really what I did is I added 12 here, so I have to subtract my 12 at the end. Then I move on to my next step. I'm going to keep this 3 out front. I'm going to write what's in here in the parentheses as a binomial squared. And then I'm going to go ahead and combine my terms. So I've got -5 minus 12, -17. So my vertex for this function ends up being at 2, -17. I encourage you to pause the video now and try letter C on your own before I put the answer up. We have a 2 there, so right, I'm going to have my 2x squared minus 12x plus 3. Then I'm going to factor out my 2, leave some space. I'm going to take half of -6, which is -3. -3 to the quantity squared is 9. So I'm going to add 9, but really what I'm doing is adding 18. So I need to subtract the 18 off the end. I'm going to rewrite this as a binomial squared. And I'm going to go ahead and combine, right? I have 3 minus 18, which is -15. And then my vertex ends up being at 3, -15. Good job. All right, to finish up these notes, I know these are quite lengthy compared to most of our notes, but we're kind of moving into our last application word problem for the day. So the height, y, and feet of a ball thrown that was thrown up in the air from the roof of a building, right? It's always something being thrown after t seconds, is given by the function y equals negative 16t squared plus 64t plus 50. Find the maximum height of the ball. So here's the thing. When I look at this, right, we have what we've been doing so far. I can use my x equals negative b over 2a from our 5.1 section if I wanted to go ahead and find the max where the vertex is and then plug it in. But since we just got through a whole section of converting it to vertex form, I say let's do that. Let's convert to vertex form, just to show that there is another way to solve these. Yes, you can definitely use this approach. It will work. It's standard form. It will. But let's convert to vertex form just to kind of practice or remind ourselves how we do this. So I'm going to group my t's together. Then I'm going to factor out a negative 16 because I don't like working with that negative. If I factor out a negative 16 though, I need to make sure that I then change this to a negative 4t. I'm going to leave some space in there. I then take half of negative 4, which is negative 2, and then negative 2 squared, positive 4. So since I added, now let's think about this for a second, right? I added a negative 64 here. That means, right, I added a negative. So back here I need to add a positive. Just think about that for a second. I subtracted up here, so therefore I must add back here. That's really kind of the trickeration of this one. So I'm going to rewrite this as a binomial squared. So I get t minus 2, the quantity squared, and then I go ahead and add these together. 114. So that tells me my maximum is at 2 seconds, right? The ball, or yes, it's a ball. The ball is at a height of 114, and let's see, is it in feet? Yes, feet. And we did that by converting to vertex form instead of using the standard form approach of me finding negative b divided by 2a and then plugging that value in. Many approaches to solving these, and that ultimately is what we're looking for in this unit. So hopefully you feel prepared to go ahead and can conduct or finish those 5.2 worksheets. Please let me know if you have any questions. One of the 5.2 worksheets is called a discovery activity. It is up to you if you would like to do that. If the notes make sense, you do not have to. The other 5.2 worksheet is the one that I am collecting for homework. All right, thanks a lot.